Hi, algebra students. We're going to be talking about the history of numbers and the real number system. And so where do numbers actually come from? The basis of algebra is the number system. And so we're going to look at where numbers developed, where numbers came from, and also a way we can classify numbers to think about them. So if you think about where did numbers even come from? In the beginnings of the study of mathematics, ancient people would have needed to know the difference just between counting everyday objects, such as one sheep versus two sheep. And even today, there are still civilizations in South America, tribes in the Amazon, that only have words for the quantities of one, two, and then anything above that is many. So these civilizations do not have words for 3, 4, 5. They just say that's one. They can look at one object and say that that classifies itself as one, or maybe another object beside of it would be two. And then above that, it's just many. There's other civilizations that only have words up to the number 5. And so here, if you'll look at the picture on the screen, this is a bone found in Central Africa amongst the people of the Ishango. And it's just a way that ancient people would count things. And so maybe, you're out in the field and you're trying to count either your livestock or maybe bundles of grain that you're taking in. And so what they would do is they would take something, in this case, a bone or maybe a stick or something, and they would just cut notches into it. And this would keep track of the basic numbers of 1, 2, 3, just counting how many they had. And so if you think about the way that numbers developed, of course, we began by counting. So ancient peoples would have just counted. And then as history and as people progressed, you'll probably learn, if you're taking world history, you'll learn about the Fertile Crescent and the sort of place where civilizations started to pop up in ancient times. Usually around what is now the countries of Iran and Iraq and Afghanistan in the Middle East. And so there was an ancient civilization called Sumer. Around the Tigris and the Euphrates rivers is where this people lived. And of course, you can see on the larger map here that this was in the Middle Eastern region. And so these people, we've actually found these corks. I'm sorry, not corks. They're clay. They're made out of clay. And just, again, it's a way that these Sumerian people would have counted things. And so you can see the different notches and different symbols that represented a way of maybe counting some sort of numbers. So after the, sort of Sumerian counting system was developed, that civilization started to spread, and eventually you may have heard of the civilization of the Babylonians. So again, there's the Tigris, there's the Euphrates, so this is in the same region in the Middle East. And the Babylonian civilization actually came up with a way of writing these numbers. So no longer were they just using sort of counting, sort of tally marks or cutting notches into bones or carving things into clay cones. But again, we're in the same region here, and the Babylonians developed a number system that looks like this. So these are the ancient Babylonian numerals. You can see that the number 1 was represented sort of by a little triangle on top of a straight up and down line. 2, of course, is very intuitive, that you would just double the number that you had that represented 1. 3 would have looked like 3 of those symbols in a row. Now 4 gets a little more interesting because they started to add more triangles to the top. Same thing with 5, 6. So it just develops from there. 10 is actually turned sideways, the triangle is, and you have 2 sort of diagonal lines now. And if you'll notice when you go back up here to the top, that 11, just like our number system, when we write an 11, we're really writing a 10 and then a 1 next to it, although we drop the 0 in the middle. 12 is 10 and 2. And so what they did exactly the same thing. If you'll notice, this is the symbol for 10, the sideways triangle with the 2 diagonal lines coming out of it, and 10 and then 1 more, which comes from the symbol of 1. So to write 11, they would have written the symbol for 10 and then 1 more. And it, again, progresses from there. So 12 is 10 and 2. 13 is 10 and 3, so on and so forth. 20 becomes 2 of those 10 symbols. 30 becomes 3. 40 becomes 4 of those symbols sideways. 50, and again, this system could just go on and on and on. So this was the numerical system that ancient Babylonians used. So again, just keep in mind, up until now, we are still just counting, right? These are basic counting numbers like you would have learned in maybe kindergarten, 1, 2, 3, 4, 5. Notice what's missing though. So up until the Babylonians, we were only counting 1, 2, 3, 4, 5. Can you think of any numbers that are missing? One of those numbers that's missing so far is the number 0. So now we're going to not only talk about the Middle Eastern region, so again where the Babylonians were living, but also over into southern Mexico, which if you know any history, southern Mexico is where the Mayans lived. And so separately from each other, of course, there were no cell phones, there was no internet, so people in the Middle East could not communicate with people in southern Mexico. However, independently of each other, they both of these civilizations came up with a way of representing 0. So the Babylonians, here are those triangles on top of the sticks that they would have used to count. So they represented 0 by, it almost looks like a 2 turned sideways. So this was their symbol for saying nothing exists here, right? So to write the number 6,007, they would have wrote a 6 and then next to it a 00, and then they would have represented 7. These two symbols meaning that there's nothing in between them, but they're placeholders. So the Babylonians used this symbol. The Mayans, however, used a different counting system. So they had developed their own way of counting, just like the Babylonians. This is the symbol which would have meant 6. If you notice, this long line actually meant 5, and so a dot on top of a 5 represented 6. Down here, 2 dots on top of a line that means 5 means 7. So that was just their counting system, similar to the Babylonians. But they would actually use the sand and the dirt to write these symbols in. And so they actually started picking up shells, and anytime they needed to put a 0, they would just lay a shell down. And so these symbols are meant to represent shells. So again, to write the number 6,007, they would have just written this symbol and then put 2 shells in the place. So Babylonians and the Mayans. So now we have 0. Now we have the counting numbers. Can you think of any other numbers that would have needed to have been developed throughout history? Well, we're going to take another trip to another part of the world. So we've been to the Middle East. We've been over here where the Mayans lived in southern Mexico. Now we're going to jump over to India, where a man named Brahmagupta, say that 5 times fast, Brahmagupta gave us the first rules for dealing with 0. So again, he was living here in India. So he made the statement, when 0 is added to a number or subtracted from a number, that number remains unchanged. So he was starting to think about doing mathematics with the number 0. He also came up with the rule that a number multiplied by 0 becomes 0. But he also was the first person to start writing about positive numbers and negative numbers. So if you think back to what we've developed throughout history so far, there were counting numbers, 1, 2, 3, 4, 5. There was the number 0, we could represent that. But up until Brahmagupta, who lived about 500 to 600 years before the Common Era, or before Jesus lived, there was no such thing as negative numbers that had been talked about yet. But Brahmagupta brought those to light. So he actually started thinking about positives and negatives in terms of fortune, or like having money or having wealth, and then debt, which is, of course, owing someone some money. So he came up with some rules about, a debt minus 0 is still a debt. If you're in debt to me and you take away none of your debt, you're still in debt. A fortune, take away 0, is still a fortune if you don't take anything away. So he started thinking about in terms of fortunes, and then negatives would have been debt or taking away. And he came up with some rules as far as that. So now, in the course of history, we have counting numbers, of course, to count our property or to count our livestock or to count anything. We have the number 0. We now have a way of dealing with positive and negative numbers, meaning having something or being in debt to someone. Can you think of any other numbers that would have needed to have been developed throughout the history? Well, we're going to go to another nation. The nation of Egypt, of course, was a very advanced ancient civilization. And the Egyptians were the first people to write and talk about fractions. And so, for example, they would have had maybe a piece of bread, and they started thinking about, well, if this piece of bread represents a whole, I need to split it up. Well, each of these pieces is no longer a whole, but a part of a whole. So the word fraction that we use actually comes from Latin fractio, which means to break. And so if you think about fractions, the Egyptians thought of it in terms of just simply breaking something into pieces. So now we have counting numbers, now we have zero, now we have negative numbers, and now with the Egyptians, we have fractions. And of course, with fractions comes decimals, right? Because decimal is just another way of representing a fraction, and percentages. So we can talk about adding fractions or adding decimals. That's what the ancient Egyptians were about. There's one last category of numbers, and that would be the irrational numbers. So as civilization progressed even further, we had men like Pythagoras and ancient thinkers who came up with and discovered numbers like pi, which of course is 3.14159 ... This is a non-repeating decimal that just goes on and on and on and on. It's one of those crazy numbers. So numbers like pi, also the square root of 2, which if you have a calculator handy, you could type in the square root of 2. And so I'm going to type in 2 and hit my square root. And again, if you'll notice, it's a decimal that goes on and on forever and ever. It never repeats. It doesn't have any sort of rhyme or rhythm to it. But it's just one of those, again, crazy numbers. So there were people throughout history who discovered these wild and crazy decimals that didn't really have any rhyme or reason to them. And so we arrive at present day. And so we have categorized what we just sort of walked through in history as the number system. We call this actually the real number system. So we think about every number that we know of or can think of. All of these numbers developed throughout history is called the real numbers. These are numbers that exist. Now, when you go into Algebra 2, you'll actually learn about something called imaginary numbers. But here in Algebra 1, we do not have to worry about that. So every number that we've talked about is called a real number. Now, if you look on the chart, you may want to have a piece of paper and maybe sketch this out yourself. We're looking at a large rectangle here. It's split into two. So there's a rectangle over here and a rectangle over here. And if you notice, there's sort of this these ovals that are inside of each other, right? And so we're going to think about these numbers that we've developed throughout history in terms of each other. So there's 1, 2, 3 different ovals. We're going to start here in this little tiny oval, and we're going to think about, okay, in the course of history, the very first numbers to ever be discovered were simply our counting numbers. So numbers like 1, 2, 3, etc. The numbers that you learn in kindergarten. And actually, instead of counting numbers, we end up calling those natural numbers. Natural numbers. I'm just going to use the hashtag for numbers if that's okay with you all. So natural numbers. Those are the numbers that come naturally to you, that you start with in kindergarten, 1, 2, 3, 4. And then, if you think back to our story throughout history, the natural numbers eventually developed. The Mayans and the Babylonians came up with a 0, right? And so the next category of sort of historical numbers we call whole numbers. And those whole numbers include all the natural numbers. So the category of whole numbers will include 0, starting with 0, and then 1, 2, 3, etc. So notice that's why we put this circle that contains the natural numbers inside of the whole numbers, because it includes 0. Now, 0 is not a natural number, but the whole numbers begin to include 0. And then as history developed, we learned about what we would now call the integers. And this is what Brahmagupta discovered, including the negative numbers. So integers would include -2 and -500 and -1 and also 0 and also all of the counting numbers. So this is what we would call the integers. And of course they go on and on in either direction, right? We could go to -5,000 if we wanted to. As long as it's a whole number that is either negative or positive, we call those integers. And then the next category, which will include this rectangle surrounding all of these ovals, is called the rational numbers. Rational. And of course, this starts to include what we talked about in Egypt. So Egyptians started thinking about not only negatives and positives and 0, but all those numbers in between, like 1/2, the fractions, the decimals, so like 0.25. And also percentages, like 2%. So any Fraction, any decimal that actually ends. Notice this is called a terminating decimal because 0.25 actually stops. It doesn't keep going. Also, if you think about fractions like 1/9, if you were to divide 1/9 out into a decimal, you'd get 0.1 repeating 11111. As long as it's a repeating decimal, we call that rational. If it's a terminating decimal, we call that rational. Anything that's written as a fraction, that's rational. Anything that's written as a percentage, that's rational. But of course, rational numbers also include all the integers, so -2, -5, -5,000. It also includes 0, and it also includes all those counting numbers like 1, 2, 3, 4, etc. The last category is this category that includes these decimals that don't ever end and also don't repeat. So these are called rational. We call the last and final category irrational. Now, we put them over here by themselves because they do not follow any of the rules of anything over here. So Tional, these are called the irrational numbers, and they include numbers like pi, because pi is approximately 3.14159, goes on and on forever and does not repeat. That's the key thing about the difference between this sort of decimal and the irrational sort of decimal. Also, the square root of 2, we said it a minute ago, the square root of 2 is approximately, let's bring it back up here again, 2 square roots is approximately 1.41, etc. It goes on and on forever, does not repeat, and does not end. So those are what we would call the irrational numbers. They're irrational, they're crazy. And so for your assignment after you watch this video, there are going to be a few definitions and some practice that you're going to do with this number system. If you've not already copied this down, you might want to get it grabbed or in your notebook and copy this chart down.
So I want to show you real quick, when I say write down your notes or put it in your notebook, here's what I mean. So for the real number system, you just want to have a composition notebook. We should have hopefully talked about this in class, but you want to get some sort of composition notebook like this so you can keep all of your notes in for this entire class. And so this is going to be the first page of notes that we write in. So what we just watched a video about was the real number system. And so we want to make sure that we write the title up at the top. And if you want to put page 1, because this is going to be the first page of notes, then for the real number system, we just want to sketch out that box in that system that we talked about. So I'm going to turn my page sideways, and I'm going to draw my rectangle in the center. So just draw you a rectangle. Remember, this represents all the real numbers. And so I'm going to write real numbers. Because this whole rectangle, remember, is all of the real numbers that we know about. And then I'm going to split that, all the real numbers, into the irrational and the rational. And remember, irrational, we'll just write a couple of examples. Remember, the irrational numbers were numbers like pi, 3.14159, etc. And numbers like the square root of 2, and really any square root that's not a perfect square. So also like the square root of 3. Not the square root of 4, because the square root of 4 is 2, and it would be a counting number. But any square root that is not a perfect square number. Like 16 would not be an irrational number, but 17 would, and 15 would. Also the square root of 101. Not the square root of 100, because that's 10, but any non-perfect square is going to be irrational. Now remember, in the rational numbers, we have numbers like 1/4 or 0.25, any terminating decimal, any fraction like 1/9, that is a repeating decimal. Also numbers like 3/5 or 0.59273 that actually end, or percentages, remember, so 50% or 1%. Now within rational numbers, we had the largest of the of the subsets of rational, which is integer, which remember is numbers like -7, -6, -5. And then we had the whole numbers, which exist inside the integers, so whole. Remember that includes 0. And then the smallest of them all is the natural, which includes 1, 2, 3, all the way up to infinity. And so when I say make sure you write this down in your notebook, that's what I mean. Make sure you grab your composition notebook and go ahead and write down this chart on the first page. That way you'll have it to look back at the real number system.
Some of the things you're going to need to know for your assignment: a repeating decimal. So just as a review from what we just talked about in this chart back here, a repeating decimal or a decimal that terminates or ends, remember, is called a rational number. That's the definition of rational. A non-repeating decimal, meaning a decimal that does not repeat and also never ends, is irrational. And of course, that's this category over here with these examples. A decimal cannot be blank and blank at the same time. It must be one or the other. So a decimal, speaking of decimals again, a decimal cannot be rational and irrational at the same time. It either has to end, repeat, or not repeat. It cannot be rational and irrational at the same time. So a decimal cannot be rational and irrational at the same time. It must be one or the other. Numbers that you count with are called natural numbers. Whole numbers include all of the natural numbers and 0. Remember, when you get to whole numbers, we start including 0 and not just the counting numbers. So whole numbers include all the natural numbers plus 0. Integers began to include the negative numbers. So when we get to the category of integers, begin to include negative numbers. And when we start classifying individual numbers, we classify them as what they are plus everything larger than them. So 1/4 or 0.25, if we look at our chart, 1/4 is of course going to be a rational number. That is a fraction. It's not an integer. It's not a whole number. It's not a natural number. It does not live inside any of these ovals. However, remember, we said at the beginning, all of the numbers included, rational and irrational, everything inside this box is a real number. So 1/4, we can say, is a rational number. We can classify it as a rational number, and it's going to be real. Now, notice this next number, 0.0235789. Notice there's no repeating here, and this ... means that it goes on forever. And what did we say about decimals that don't repeat and go on forever? Well, if we look back at our chart, those are the irrational numbers. Now notice, if you're irrational, you're also a member of the real number category. So for this, for classifying 0.0235789, this is going to be irrational. And it's also going to be real. 0, if we look back at our chart, 0 of course begins with the whole numbers. So 0 is a whole number. It's not a natural number. It starts with the whole. But notice whole numbers also are included in the integers. And they're also included in the rational numbers. And they're also, of course, included in the real numbers. So a 0 is going to be a whole number. It's also going to be an integer. It's also going to be rational. And last but not least, it's always going to be real. You can safely assume everything we're talking about is going to be real. Last two, examples. -7 can be classified as, let's look back at our chart, -7, remember the negative numbers started coming about with the integers. So of course, -7 is going to live in the integer category. It's not whole, it's not natural, but it is inside of the rational family. It is also a real number. So for -7, it can be classified specifically as an integer, but also as a rational, and of course real. And last but not least, the number 1493. If you can count to it, you can safely assume that it is a natural number. It's all the numbers that you can count up to. So our number there is going to be natural, but remember the natural numbers live inside the whole numbers, so it's also going to be whole. It's also going to be an integer. It's inside the rational family, and it's also a member of the real family. So our last number, our counting number, anything that's a counting number is going to be classified as a natural number, because you can count to it. It's going to be a whole number. It's going to be an integer. It's going to be rational. And of course, it's going to be real. Now, you can move on to your next assignment and practice with some of these number categories, thinking about number history and the real number system.